and we are going to get introduced to the three big ideas of trigonometry for grade 12. Trigonometry in grade 12 connects triangles to circles. So first of all, we're going to get introduced to the unit circle. This is the unit circle. We can take out our highlighters. If you did a radius of 1 and made a circle starting at the origin, we call this the unit circle because its radius is 1 unit. And it happens to be perfectly at 0, 0. Now if you took any point on your unit circle, and so we've chosen this point here, you can make a triangle with the nearest x-axis. This is going to be important, connecting to all those other ideas. So we go to the nearest x-axis, so we have a reference angle. You can make a triangle, and this length would be whatever your x-coordinate is, and this length will be whatever your y-coordinate is. So the equation, if you used a squared plus b squared equals c squared, you get x squared plus y squared equals 1, and this is actually the equation of a circle. If you could graph it on a graphing calculator or on a program, it'll make a perfect circle. X squared plus y squared equals 1, because it will go through every single point where that works, and that makes the whole circle. Okay? Now, as we get to our big ideas, here is big idea number 1. If this is my angle theta, so I want you to label that in there, then I could write that sine of theta is the opposite side over the hypotenuse. And if I do that, I get just y. I could write cos of theta as the adjacent over my hypotenuse, which would give me just x. And I could write tan of theta as opposite over adjacent, which would be y over x. What this does is give us our first big idea. If a point is anywhere on this circle, we could call it x comma y, but we could also call it cos theta comma sine theta, because the x is equal to cos theta, and the y is equal to sine theta. So at the bottom of page 470, we can now write our first big idea. Big idea number 1. Big idea number 2. Since the equation of the unit circle is x squared plus y squared equals 1, and the x is equal to cos theta, and the y is equal to sine theta, we can now say that cos theta squared plus sine theta squared is equal to 1. Because cos is x and sine is y. Mathematicians don't like brackets. Whenever we ask you to simplify, usually that means get rid of all the brackets. Brackets seem to be messy, okay? So I'm going to show you the proper notation for writing this without brackets. Mathematicians also ran into a problem here. They said, if we just take away the brackets and just leave the little 2, how do I know if the whole thing is squared or just the angle is squared? This is a problem. So what they decided to do is when the whole thing is squared, we write the squared in between the cos and the theta. And on your formula sheet, sine is a little bit of a goalie. It always wants to go first. They always write sine squared theta plus cos squared theta equals 1. And that formula is on your formula sheet, which I haven't given you yet. I'll give you maybe tomorrow. So here is big idea number 2. Put a blue box around it. Sine squared theta plus cos squared theta is equal to 1. Mental math, what does this mean? Okay? How good is your mental math? What is sine of 42 degrees to 10 decimal places? Anybody? No. Right? Sine of 42 to 10 decimal places, it doesn't even. Yeah, I got 10 there. Perfect. There we go. I'm sure that was just on the tip of your tongue. Probably got stuck at decimal place number 5, right? Now, you're pretty good at mental math. Square that, right? If I just take that answer and I square it, what is 0.66913066064? And hopefully you know the other decimal places, and you square it, right? Were you close at 0.4477? Now, if we did the same thing with cos of 42 degrees, and then I squared that one, and I took the sine squared answer. Wow. There's my sine squared answer. And I add my cos squared answer. I get 1. Every single time. It doesn't matter what angle I have. Sine of 13 degrees, all squared. Plus cos of 13 degrees, all squared, will always equal 1. This is super important and comes up a lot in higher level math, and so it becomes our second big idea. And our third big idea is with tangent. On the unit circle, we saw that tangent was y over x. What does that mean? If the y was always sine, and the x is always cos, we have our third big idea. That tan of theta will always be sine of theta divided by cos of theta. Let's try it with, well, we're using 42. I'm enjoying that number right now. I don't know why. 42 seems like a fun number to use. So if I do sine of 42, and I divide it by cos of 42 degrees, and push enter. And now I check what is tan of 42 degrees. It works out perfectly. Every single decimal every single time with every single angle. Crazy. Well, these three big ideas are going to come up over and over and over again in this unit and the next unit. In fact, if you're stuck on a question, you might ask yourself, is one of the big ideas helpful here? Would it help me solve this? Is there a way that I could use one of these big ideas to help me figure this out? Also on page 470, we are going to get introduced to three more trig ratios. Grade 10 and 11, we dealt with sine, cosine, and tangent. In grade 12, we add the three other ones, secant, cosecant, and cotangent. And all they are reciprocals of cos. So secant, I'm going to get you to write this off to the side. Secant of theta is the same as 1 over cos of theta. And that means that cos of theta is equal to 1 over secant theta. They're reciprocals of each other. With sine, you have cosecant. So cosecant theta is the reciprocal of sine, so that means that sine of theta is 1 over cosecant theta. And cotangent theta is 1 over tan theta. So that means tangent of theta is 1 over cotangent of theta. And the word reciprocal for a fraction means that your numerator and denominator are going to get switched. You're basically flipping your fraction when you have a reciprocal. The first time you heard the word reciprocal was probably when you learned how to divide by fractions. Your teacher might have said when you're dividing by fractions, you need to multiply by the reciprocal, which meant you had to take the fraction on the bottom and flip it and then multiply. So this idea of flipping a fraction, switching the numerator and denominator, is called the reciprocal. And these are our new trig functions. Secant theta is the reciprocal of cos theta. Cosecant theta is the reciprocal of sine theta. And cotangent theta is the reciprocal of tangent, but if cotangent theta is the reciprocal of tangent, and our big idea says that tangent of theta is sine of theta over cos of theta, if I take the reciprocal of that, that means that cotangent of theta is cos of theta over sine of theta.